Assalamualaikum dan selamat sejahtera. We continue with the 7.3 solubility equilibrium. Now we want to try several questions to more strengthen about Ksp and molar solubility. Right, question number 1 here. Silver bromide, okay, is the light sensitive compound used in nearly all photographic film. Okay, the molar solubility AgBr is 7.1, exponent negative 7 molar. Calculate Ksp. As I said before, if you want to calculate Ksp, no need ice table. Alright, no need ice table. When I said ice table, you already familiar about ice table. That means before table you have to write the equation, and then you have the row initial, change and equilibrium. Okay, first of all, what you have to starting, okay, you must start with the equation. Equation what? Equation of your ionic compound dissociate. Okay, dissociation of your ionic compound. So lah, right? So we call as ionic compound, right? Call as ionic compound. Okay, so for this case, AgBr solid. Why I use the reversible arrow? Because this solubility equilibrium we focus to form saturated solution. Okay, what means by saturated solution? The solid and aqueous exist in equilibrium, seimbang antara amount solid dengan amount aqueous, dissolved dengan undissolved. Alright, so produce its ion Ag plus aqueous and Br minus aqueous. Okay, given for us is molar solubility of AgBr. Okay, that means concentration of AgBr is similar with concentration Ag plus, similar with concentration Br minus. Why I said similar? Because from this equation, all the stoichiometry is 1, 1, and 1. Alright, so after you check the concentration of AgBr is similar, which is 7.1 exponent negative 7, you can proceed the next step by write the Ksp expression, okay, which is concentration Ag plus power its stoichio multiply concentration Br minus power its stoichio. Then you just include the molarity of Ag plus. It said molar solubility, but at the same time this is your concentration. So sama saja molar solubility dengan concentration. Okay, but this case kita tak sebut concentration sebab kita melibatkan ionic compound, right, yang slightly soluble. Right. Okay, so for this case you just insert the value of concentration Ag plus and concentration of Br minus, and you get the answer here, 5.04 exponent negative 13. This is your answer. Okay, this is the value Ksv for AgBr. Don't worry, your value is very very small, negative 13, like negative 20, negative 35. It's okay because this focus to the value of Ksp for slightly soluble ionic compound. Okay, that's why the value is very very small. Okay, question number 2. The solubility of silver carbonate is 0.032 mole per liter at 20 degrees. Calculate Ksp. Again, calculate Ksp. means that no need, I stable. Okay, so this time it just said solubility. Okay, but this solubility should be in gram per liter. From the previous video, I said the unit for solubility is gram per liter. Back to the definition solubility. But sometimes the solubility given in unit mole per liter. So that means this is your molar solubility. Okay, so sama saja. Right? So first of all, you have to write the dissociation, your ionic compound. Okay, which is your ionic compound is silver carbonate. Kalau tak pasti apa dia punya molecular formula, you write the species secara independent first, and then you cross the charge and you get the molecular formula. Solid. Alright, Ag plus and carbonate. Okay, cross the balance the equation 2 here and write the phase, and then check the concentration. Give the silver carbonate, that means concentration Ag2CO3 is 0.032. Is it same with the concentration Ag plus and CO3 2 minus? No, because stoichio is 1 to 2 to 1. So that means concentration Ag plus is 0.032 multiplied by 2, because the ratio here is 2. Okay, so you get the 0.064. How about concentration CO3 2 minus? Yes, concentration CO3 2 minus is similar with concentration Ag2CO3, because the ratio is 1 to 1 equals to 0.032. After you get the concentration, okay, concentration means the molar solubility that I said before. Concentration itu sama dengan molar solubility because the unit is mole per liter, right? So after you get the concentration for each ion, you must write the Ksp expression first, which is Ag plus power its stoichio multiply carbonate. Then you insert the value that you calculate before. Square here, jangan lupa ini nilai untuk Ag plus kuasa 2 masih kekalkan, dan masukkan nilai 0.32 concentration untuk carbonate, and then you get 1.31 exponent negative 4. This is your Ksp value. Question number 3. The solubility of calcium sulfate is found experimentally to be 0.67 gram per liter. Calculate the Ksp for calcium sulfate. Okay, again, you want to calculate Ksp. That means no need, I stable. Okay, so you have to start with the equation, dissociation ionic compound. Dissociation ionic compound, which is your compound is calcium sulfate, calcium Ce2 plus, sulfate SO42 minus. Cross the chart, you will get the formula of the ionic compound. Right, Ce2 plus equals and SO42 minus equals. Then you write the Ksp expression. Concentration Ce2 plus, concentration SO4 to minus. Now, if you want to insert the value concentration Ca2 plus, you must refer the concentration of calcium sulfate here. Given solubility is 0.67 gram per liter. Okay. Solubility. Calcium sulfate is 0.67 gram per liter. This unit, based on this unit, this is not molar solubility or concentration, right? So if you want to insert the value into this Ksp expression, you must use the molar solubility. The unit is mole per liter, but now in your hand you have unit gram per liter, so you have to convert first into mole per liter. After you get into unit mole per liter, then baru you insert into the Ksp expression. So how you want to convert? Okay, now I want to show you. If you want to convert gram per liter to mole per liter, you have to divide by molar mass of the ionic compound. If you want to convert from mole per liter into gram per liter, you have to multiply by the molar mass of ionic compound. You must remember this. Okay, so for this case, you have to divide by Mr. Mr for calcium sulfate, your ionic compound. Alright, why I say like that? Because if you have 0.67 gram per liter, you divide by molar mass, iaitu unit dia gram per mole. So you akan jadi 0.67 gram per liter multiply by mole per gram. So you cancel out the unit and then you'll get the value in unit mole per liter. For this case, you want to divide 0.67 divide by Mr. Mr for calcium sulfate already given 136.2 gram. So di sini pun 136.2 gram. So that's why 0.67 divided by 136.2, you'll get 4.919 exponent negative 3 mole per liter. That's why we keluarkan this formula. Nak tukar gram liter pada mole liter, kena divide. Kenapa kena divide? Sebab nanti baru dia akan dapat unit mole per liter yang kita nak. Ini cara dia. Okay, for this case, dekat sini you hanya tukarlah. Alright, so solubility calcium sulfate equal to 0.67 gram per liter divide by 136.2 gram per mole, and you will get 4.919 exponent negative 3 mole per liter. You just write like this. This is how I want to show you, how you get the gram per liter to mole per liter. Right. Okay, after you get the mole per liter, molar solubility, then you will insert into the Ksp expression. Directly insert because of what? Because the ratio calcium sulfate to Ca2 plus and SO4 to minus is 1, 1, and 1. That's why directly insert. right? And you get the 2.42 exponent negative 5. This is your answer. Question number 4. What is the molar solubility of AgCl in pure water? Ksp AgCl is given. Okay, now what is the molar solubility? You want to calculate molar solubility. That I said before, you want to calculate molar solubility. That means you needed I stable. Okay, you want to do I stable, you have to write the dissociation of ionic compound first. Alright, so your compound is AgCl, Ag plus Cl minus. Okay, I stable, initial, change, and equilibrium. All the time your I stable in unit molar. Okay, so since it in solid phase, not involved in your table, your Ag plus does not produce yet, will become 0 at initial. Change, you put the unknown, like chapter 6, we put the unknown x, right? But for chapter 7, you write the unknown s. Why s? S stands for solubility. So, here also s. Because the Stoichio is 1 here, that's why it's 1s. Stoichio is 1 here, that's why the s is 1s. Since both of these ion is product, you put the positive sign as usual, right? So your equilibrium 0 plus s will become s, 0 plus s will become s. This is your I stable that you must complete. Okay, after you do the I stable, automatically, like before, after I stable, Ksp expression, right? But for this, not Ksp expression, Ksp expression. Okay, then you insert the value. Ksp already given 1.8, exponent negative 5. Sorry, negative 10. Sorry, negative 10. Right? Your Ag refer to the row equilibrium, which is S. Your Cl minus refer to the equilibrium, also S. And you get the S here. You calculate using calculator. You get 1.342 exponent negative 5. Okay. This is not your answer. Please answer the final with the complete sentence. Thus, molar solubility of AgCl equals to 1.34 exponent negative 5. Unit compulsory molar. This is your answer. You do not give in S only, because I don't know what mean by S. Okay. Okay, the last question, Q. Question 5. Calculate molar solubility PbCl2. As usual, you needed I stable. Okay, so starting with the equation. Your dissociation ionic compound. Pb2 plus Cl minus equals, balance the stoichiometry 2 here, initial, change, and equilibrium. All the unit I is in molar. Solid not involved in your I stable, This is 0 for inertial, right? That's not produced yet. Positive, positive, because product. Since Tokyo is 1, only put S. Tokyo is 2, will become 2S here. So 0 plus SS, 0 plus 2S, 2S. Complete your table. Make sure you write in the correct column. Okay? After table, Ksp expression. Okay, Cl minus power is Tokyo. So, substitute the value 1.6 exponent negative 5. Pb concentration refer to the row equilibrium here. S. This is 2S. Square, jangan lupa. So, di sini 1.6 exponent negative 5 will become 2S squared will become 4S2. Okay, 4S squared. 4S squared multiplied by S will become 4S cubed. Alright, so you settle down, you get the S 0.0159. Thus, molar solubility of PbCl2 is 0.0159. Include the unit. Okay, so extra exercise here you can try by question number 1, number 2 and number 3. I will check later.